Yeah, so now we're gonna do colors. We sampled all these different horizons out of the pit, and the first thing is to just take a look at this beautiful, beautiful, beautiful pedon, and think about the processes that are playing out and causing these different colors. So what are the coloring agents? We've gone over this before. We've got organic matter, major darkening of soils. We have iron oxides of different hues and shades. We have, hematite, it's really red, and lepidocrosite and ferrihydrite, and all these different iron oxides that have red to orange to yellow colors. And so talking about how soil genesis sort of intersects with morphology, we talked about the landscape, we talked about the vegetation, and we talked about the climate here. So there's a lot of rainfall. And so when you look at this soil profile, you think about what is being input into the soil profile, what's causing these colors, right? The morphology is the colors, but what are the processes that lead to these colors, right? So if you see you've got this darkening at the surface, again, thinking about vegetation, forest soils, its inputs, its carbon, photosynthetic carbon being fixed by all these huge trees and being put into the system, darkening the soil surface. And then we think about that clay factory, right? That weathering process on this andesitic, this fine-grained material, all this energy pumping in, all this rain, all this hydrolysis, and things pushing this clay deeper down in the soil profile. And you can see some of that clay iron oxide weathering there in that subsurface horizon. So the point is, what I just want to focus on is inputs at the surface are one thing coming from the biota. That's contributing carbonic acid, causing these weathering processes. They're then pushing the clays deeper down in the profile, and you can see that in the morphology, and we'll see that again when we look for clay films. But just kind of looking at color, it's just a great example of two different pedogenic processes. One, lessivage or translocation. The other one, inputs, right? You've got inputs of organic matter in the surface, you've got translocation of clays, and you can see that in the color and just how this profile is laid out. So now let's get to the meat and potatoes of getting some colors. So we look over, so this is our first mineral horizon. I looked through different color pages. It's a little bit red, so I went with the 7.5 YR page instead of the 10 YR page. So always over the left shoulder, always with the sun behind you. Are we gonna be able to get this?
Yeah, we can walk out. Let's walk out to the sun. And then I'll
make sure you have your sunglasses off, which is hard for me.
And then I gotta get the right light.
I'm gonna go 4-4. Maybe 3-4. 4-3, I mean. So I always blur my eyes a little bit. So we're gonna go for the 7.5 YR 4-3, dry. These soils are pretty dry. So we got 7.5 YR 4-3 for that first horizon. This is the second horizon down, second mineral horizon down. I'm gonna call this a 4-4, 7.5 YR 4-4. A lot of times it never really fits one perfectly, but you got to make a call. Make a call, stick with it. Help it, as Garrett was saying, help it kind of inform the story that you're developing about the soil. So that one's 7.5 YR 4-4 dry. Next one. Whew. We might need to go to a redder page.
From 10.
From 7.5 to 5 YR. Let's bust.
5Y or 5YR?
5 YR. Let's go to 5 YR. All right.
Can you see that? Like clearly, we went down to the X horizon and we moved from 7.5 to 5YR.
Yeah. Yeah, so we were moving from the sort of more influenced by the organic matter to the next lowest horizon that was, really strong structure, clay films, and it's much redder. And so we moved from the 7.5 YR page to the 5 YR page. So yeah, that looks like it's gonna fit a little better. Woo! This thing is red. Not a great fit on this page, but we're gonna make a call. I'm gonna call it 3-4. Or if you got any
I'm not looking. Yeah.
sage advice. All right, let's
Oh,
go.
that one looks good right where you had it.
Yeah, 5 YR 3-4.
In Stockton, like the inverted islands,
Oh.
it's just a potato field.
Yeah, I've never been there.
Yeah.
So I went back to the 7.5 YR page for the next lowest horizon. I'm gonna call that 4-6. So 7.5 YR 4-6 dry. And then the very bottom one. Yeah, you might be able to call this structureless now that I'm in the.
The other one that's bring to your attention is that this third mineral horizon, it's almost, I mean, it's starting to get angular. The structures are almost getting angular.
I'm gonna call that 4-6 as well. 7.5 YR 4-6. All right, let's whip through these, wet them up. Look at that hydrophobicity. Let that stop being shiny. While I'm doing that, I'm gonna blast another one of these so that it'll stop being shiny when I need it. These ones are probably a little bit wet still, so the colors are probably off. Probably should have let them dry in the sun a little bit, but what are you gonna do? It's the coronavirus. We're doing the best we can out here on our virtual field trip.
And don't let the perfect get in the way of the good.
Yeah. All right, let's take a look here, Irf, if you don't mind. I always feel strange ordering people around.
No, that's fine.
Woo! That's a perfect match for 3-3. So 7.5 YR 3-3 at the surface wet. All right, next one down. Southard would have had us putting these out to dry when we first got here.
Right.
To get good color.
Sample them so you could do, and like I said, that's where, for me, some of this stuff, if it's that important to you, you do it later.
3-4.
You actually make these measurements later.
7.5 YR 3-4.
Well, that's what when talking to Andrew, he's like, yeah, I used to do it all out there, and then now I just bring as much back as I can and just do it in the back of the truck.
That's how we got to. We not so much the laughing, but like just that reality that the idea that you're, especially because the big switch was they used to never take samples, so they would go out and that field sheet would be the
Only thing that they brought back.
I'm calling that 3-4. 5 YR 3-4. Let's see. That doesn't jive though. It's darker. Maybe I should adjust the last call. Yeah, 4-6. So I'm gonna adjust the dry color on this one to 4-6 and go 3-4 moist.
All right, I better start. Okay, naked.
This is the last horizon. I switched actually to the 10 YR page because it looks like it's starting to get a little more yellow, and that's a good match. 10 YR 3-6. So we're gonna go that. That's moist. Like I was saying, I think these were a little bit moist at depth, so we probably should have gotten a little bit higher value dry colors. Okay, cool. Well, boss, we got 15 minutes.
Yeah, I mean, it's up to you. Like I said, I've definitely fallen on the side of like, if back in the day, and in alluvial soils where you're making fairly refined calls on horizons based on texture as part of your story, sure, you got to do it all right there to make sure, right? If it's a validation of something and you know that these horizons aren't really, the texture is not really the deciding factor, then it's not as important to do it all in the field.
Yeah.
People used to not take samples. They used to just write it all down the field sheets, and they had to do it because there was no other way around it. Where now people will take samples, and like I said, Andrew will go sit on his tailgate outside his office and texture everything and lay them all out, and work on them as a study in hand texturing, not a process of filling in the sheet, right? So
yeah, we would do that too.
you know,
Even if we just take them to the truck,
right?
do them in the tailgate over lunch,
Right.
type of thing, you know. So let's do the O horizon. I always kind of I always do the texture of the O horizon and then break it out, break the texture ball in half to do color. So what is it? Most of the vegetative material visible is OE or
It's O-I-O-E-O-A, or is it O-A, O-I-O-E? One's Himic, Fibric.
one OIOEOA.
Okay.
Initial, intermediate, and advanced.
Oh, that's a great way to remember it, huh?
The interface stuff that doesn't have any features that look like the stuff that. So this is probably an O. This is probably.
OI.
It's got the char material on the top. You could have broken out 2 O's on this if you really wanted. This stuff, and then there is like the I or A stuff broken off, or the E or A stuff underneath.
I wouldn't call chipped material O horizon.
It's still organic.
Yeah.
I mean, just because it didn't fall off the tree doesn't mean it's not an organic horizon, right?
You can kick rocks on that one, dude. I'm just joking.
It's like urban soil.
Yeah.
What is a fucking overburden of clay sediments over sand? I mean,
Yeah.
it's just because we envision this perfect world with O horizon being pine needles. This is an O horizon. It's organic. It's just shredded material.
But I thought if it wasn't like in the duff layer, like starting that decomposition process, then it wasn't.
But it is. It is. You see it in here breaking down, right? It's breaking down. So I'm just saying, you could argue, this is the lumping and splitting, that you could have easily called 2 O horizons on this. One is the chip,
Yeah.
and the other is this, breaking down layer right at the mineral organic surface.
You can save that one for the soil judging competition to split out the breakout for like the top winners, if they put the carrot, as the horizon prefix or not.
A carrot O horizon. That's a new one, dude.
Well, I'm just saying, like, at the soil judging competition, that would be something that all the people that care would complain about.
Yeah.
And I'm not in that group. So, I'm just saying, why is this not, what makes this not O horizon? So I would go not that my rule is right, I would ask, why is your rule right?
Right. So
And I'm not saying that I'm right.
Well, and the reason I call it is because I didn't see it as being incorporated into the duff layer and decomposing from my field call.
What are fresh pine needles on top of the old duff? I mean, it's the same thing. It's just organic matter on the surface.
I wouldn't call the very, very top pine needles O horizon though.
Yeah, that's the OI. It's the undifferent. It's off the tree, but it's no longer alive.
Yeah.
And then the partially broken down stuff is the intermediate, and then the stuff that's, doesn't look like anything but, humified material. I hate using humified material, but then that's the most decomposed. But pine needles are definitely part of the sequence. Right? So either way, it's a good discussion to have. I'm sure people have thought about it. I'm sure people have characterized it, and people have opinions. Strong. I'm not saying we should change it. I think the old call was great. I'm just saying that why is this manipulated material not considered override? I just don't understand why it wouldn't. That's
So,
me.
I'm gonna call this material OE for intermediate, and then I'm gonna put it at 10YR 22. So you can see there's still a lot of visible material. I overworked it too, but I would call that good OE material. Okay. And then the dry colors. Three, 2, and 2, 2. All right. Clay films. So I'm not even looking for clay films in the surface. I didn't see any in the pit, so in that upper 8 centimeters of mineral, we're not going to look at it. Look for it. It's beautiful hyphae in here, but yeah, there's some clay films
There are, dude. There's got to be.
in that second.
Let me look.
Yeah, I got some. So there's some clay films in this channel here. It's a little hard to see. It might help if I wet it
Yeah,
up.
I mean, you look at little gravel. Like coarse sand or fine gravel, and they're coated, right? They're coated. There's some bridging going on in there.
I've got a root channel that's pretty good.
Yep. No, I'd have no problem. And I
Give
think
me
that there's
1 second.
certainly accumulations of clay that are making it as coherent as it is. The one I always use is, the one I always use is if it leaves a pocket, if it looks, oh, sorry, dude.
Oh, getting your false O horizon all over me.
That's O horizon, dude. That stuff's O horizon. Those needles are O horizon. I'll die on that hill, right? So what I always say is if you look at, you break open an aggregate,
Yep.
and if you see clear
Yep.
pockets and recesses that aren't particles, then it's clear that there's a clay accumulation. There's enough clay to have those pockets hold there. And there's a little nice one. Look at that little piece of charcoal.
And I agree with this too. Like you can see that root channel. That root channel's got sun.
Look how coated that gravel. I mean, that thing's coated almost. That little gravel right there. I mean, it's got a little knife mark or a hyphae, and it's like coated almost. That stuff, right? That one right there is great, right there. That little pocket, right in there, right there.
Yeah.
That little pocket. There's a little receiving spot just to your right of that white dot. That little spot right in there. If you turn it up like this, oh, I broke it. You can see it better now. Like right, that pocket right there. You can see that it's got a recess of other stuff that was sitting there, and that's the film. And then the gravel or whatever else that popped out is gone. But those little pockets, that's what I look for
channels and stuff mostly. Sure. But yeah, this definitely has nice clay films on the surface. But let's get into the one that's got really strong clay film. So we'll call these Ped and Void for surface features. So we're in our second. So we got NA, and then we're gonna go like 10%. Where's the red book? So I just broke open this ped. This is from that really red horizon, the third mineral horizon, fourth horizon from the bottom. So what is it, 30 to 60, 29 to 62. And you can see this whole surface is a clay film. It's distinct color from the matrix. It's a little bit darker. And you can see kind of waves on it. And just also the ped sort of parted along that line. You can just see, I forgot my hand lens, but you can see sort of that waxy cutinous surface feature. So I'm gonna call this like 25% clay films. So 25% CLFs, distinct. And what do we call it? We call it continuous if it's entire surface color. No, I'm not going to go that far. Surface of heads. All right, and then the second one down, second one from the bottom. I think technically you should color the clay films, but I'm not going to do that. I know I saw clay films in the pit on these ones. Yeah, I think these are clay films right here. Helps kind of if you zoom out actually. These are some clay films in here and in here. So we'll bring the number down. See if we can find some in this root channel. Yeah, here's another one on that little paragravel. And these little channels in there. So there's some strong clay films in there. We'll call it, I'm gonna bump up my below to, oh no, I'll call this one 20%. So they're on the gravels, they're in the channels, they're on some of the ped surfaces. So we'll call 20% CLFs, distinct, frags, rocks, frags, peds, channels.
Oh, the
we're
shade
almost
moves
done.
around.
Okay. Last one.
That was in the shade when we got here. Yeah. That perfect first shot. This will be a good one for night light, though. I didn't realize because I was down one way.
All right,
this
this
is
is
good on evening.
Oh, yeah, no,
Last Horizon also has clay film. So there's clay films all the way down.
And that's
Okay.
why it's
Whatever it is.
U-Mall,
Yeah.
And what's
whatever.
so what do clay films represent?
Clay films are evidence of the translocation of clay. As Souther always says, soils are clay factories, right? So again, that carbonic acid weathering in the surface, all this heavy rainfall, driving all those kaolin clays either as fine particles in suspension, or also translocating silica and aluminum in solution and moving that down, and then neoforming things like kaolinite along the surfaces. So I think the jury's still out. It's a combination of moving fine clay down through the soil profile from that generation in the upper profile, and then also moving fine clays or moving aluminum and silica and then neoforming clays.
Dehydration reaction. So
And then the
the
dehydration
reality
driving
that
crystallinity,
as the water film dehydrates, you get increased concentration because there's no gas phase or loss of those ions, and the concentration increases, and equilibrium predicts that solids will form. So these aluminosilicates form from increasing concentrations of silica and aluminum in solution every year. So in strong wetting and drying environments like we have here, you have probably more towards a stronger component of the neogenesis in situ formation versus translocation of fine materials from the upper part of the horizon. You get that wetting and drying cycle that over time starts to promote the nucleation of those crystals and the formation of those minerals.
Yeah, so that Oswald ripening, right, drives that sort of crystallization from driving out that soil water, you know. But I mean, I don't know. I mean, is the jury's still out, right? It is fine clays moving and neogenesis,
All
right?
the above,
Yeah.
right? But just saying that, like, I always use the contrast between the humid regions like Georgia and California, where in places that are humid and in those moisture regimes, the soils never dry out. And in many cases, when they dry out, they irreversibly harden, like in plinthite. Here you get a strong seasonal wet and dry period where you get a reasonable amount of dissolution during the wet period and then a strong drying component. So any ions that are moved down in the profile can become concentrated as that soil moisture starts to drop and starts to form those. So you can find oxides and early kaolinite and things very quickly in some of these profiles because of that cyclic wetting and drying that we find in our Mediterranean climate.
And that's what's so clay films are like one of my favorite things. They're so cool because they integrate all their morphological feature, right? And then what is it? Additions, removals, translocations, and transformations, right? They're all embedded in that clay film, right? So you've got additions of carbonic acid and different things that are driving weathering. Should we pause while the chopper goes by?
If you really want to, yeah.
Can't run from the ghetto, bird.
Police in helicopter, search for marijuana. Soldiers in the herb fields, looking for Cali weed. Oh, dude, that's straight up searching for Cali weed, dude.
The camp.
Yeah, they got the door open and shit. They
I
are.
would be all on that. I think that would actually be fun.
Mounted to the side.
No, that's definitely a copper chopper, dude.
It had no number on the bottom, like the whole thing.
Just
This
the
is
way it was banking and the color and the height that was, you
We're
know.
going right into the little area wherever.
One thing that's so cool about clay films is they sort of encompass all of those processes. They integrate, right? Yeah, so they integrate the morphology, right? Clay films are something you observe in the field. They tell you something about the taxonomy, right? They tell you if you have an argillic horizon, which then, gives you an alpha sol and ultrasol. So it ties into taxonomy, and then those basic things of additions, removals, translocations, and transformations, right? So you've got the additions of organic matter and carbonates, carbonic acid and organic matter and water and energy in the surface, right? That you're doing the hydrolysis, that primary weathering of those, weathering of those primary minerals, right? So you're getting clay into solution, or you're getting iron, or you're getting aluminum and silicon solution. Then that's your inputs. You got your transformations, which is going from primary minerals to clay minerals. Then you got your translocation, which is those clay minerals and or precursors to clay minerals translocating the soil profile. And then additions, removals, and then it's removing. So you're moving aluminum and silica from the upper part of the profile. So you've got morphology, the clay film. You've got taxonomy, argillic horizon. Then you have additions, removals, translocations, and transformations. You're forming clay minerals in the surface from the addition of carbonic acid and water and energy. You're translocating those lower in the profile. You're losing stuff from the A horizon, moving it to the B horizon. You integrate all those things in clay films, and that's why they're my favorite part of a soil profile.
In one definition, can you just clearly define neoformation?
Said it now.
Yeah. So neoformation, that's just a fancy word for saying that it's been reformed. It's something new. So clay minerals are not primary minerals, right? So you've got a potassium feldspar that's going to weather to a kaolinite. And so when it forms kaolinite, that's neoformation. And typically you use neoformation to sort of indicate aluminum and silica and things going into solution, being moved, and then reforming into secondary clay minerals. Garrett, what do you think?
I mean, that's, yeah.
No,
B minus?
no, that's all.